In this video, we are going to continue our study of the metric system and measurement by looking specifically at measuring volume. So let's look for a few moments at the difference between English and metric units of volume. Some of you are familiar with the English, others of you are more familiar with the metric. But let's look at some comparisons. So if you look in the upper right corner here, you see that 1 fluid ounce is approximately, or just under, 30 milliliters, and a 12-ounce can of soda would be about 355 milliliters. A quart, and in this picture is a quart of oil, is a little smaller than a liter. In other words, a full quart would be about 0.946 liters, or almost a full liter. If you look down here, you see that a gallon is equal to 3.79 liters. So 4 liters, therefore, is a little bit more than a gallon. It would take approximately 3 3/4 liters to fill up a gallon. So what is larger, a liter or a gallon? And as you probably already know, a gallon is going to be bigger than a liter. How about a liter or a quart? Well, there's 4 quarts in a gallon, but there's 3.79 liters in a gallon. Therefore, a liter is a little bit bigger than a quart. And finally, what is bigger, a milliliter or 1 fluid ounce? Well, as we just talked about, 1 fluid ounce is equal to almost 30 milliliters, so 1 fluid ounce would be bigger. Now let's look more closely at metric system and volume. Remember, volume is the amount of space an object takes up. The base unit of volume in the metric system is the liter, which is represented by a capital L. And more specifically, 1 liter is equal to 1 cubic decimeter. And you remember that a decimeter is 10 centimeters. So if we look at the picture here, if you had a cube that was 10 centimeters tall, 10 centimeters wide, and 10 centimeters deep, that would be equal to the volume of 1 liter. So 1 liter would be 10 times 10 times 10, which is 1,000 milliliters. So, what would be larger, a liter or 1,500 milliliters? Well, we just said that 1 liter is 1,000 milliliters, so 1,500 milliliters would be bigger. How about 200 milliliters or 1.2 liters? Well, 1.2 liters would be 1,200 milliliters, so of course that's much bigger than just 200 milliliters. And question C is a little harder, but what is bigger, 12 cubic centimeters or 1.2 milliliters? And the answer is 12 cubic centimeters. We'll talk about this more in class, but 1 cubic centimeter is equal to 1 milliliter, and so therefore 12 of them would be bigger than 1.2. Okay, now we're going to look at measuring volume. We've already used graduated cylinders a bit in class, but graduated cylinders are going to be the way we're going to find the volume of liquids most often in class. And there's a graduated cylinder picture here. You can see it's filled up with a liquid. And we're going to use the scale on the graduated cylinder to determine the volume of liquid inside. So if you look at this close-up view, you can see where the level is of the top of the liquid, and from that you can look over and see what line it corresponds to on the scale. In this case, it would be 41, 2, 3. 43. So the answer, what is the volume of water in this cylinder, would be 43 milliliters. Now you'll notice, when you look at a graduated cylinder, the water, or whatever liquid is inside of it, does not form a horizontal level line. There's a bit of a curve to it. And we call this curve a meniscus. And the meniscus forms because the water is attracted to the glass, and so it gets pulled from the middle out, which causes this curve. It's really important when we read volumes on graduated cylinders to be sure that we're looking at the bottom of the meniscus. That's where we want to get our reading from. So let's practice reading some volumes from graduated cylinders. So we'll first look at A. Now you'll see from these pictures that there actually is no meniscus in these pictures. But if these were real graduated cylinders, you would see that that curved shape at the top. So looking carefully at the scale of each graduated cylinder and where the top of the volume of water is, let's see if you guys can figure out how much volume is in each of the graduated cylinders. So for the first one here, if you look carefully, it appears that there's about 52, and we can assume that we're talking about milliliters here. So hopefully you saw the 52 in A. In B, I'll give you a moment to look at it. And the correct answer is 37 milliliters. Okay? And in C, it's a little more tricky. If you look carefully at the scale, there's 20, then 22.5 would be the line in between 20 and 25. So perhaps this is around 23 milliliters. Hopefully you guys see that. The last thing we're going to look at in this video is measuring the volume of a solid. Now you'll see the top part of this slide shows how to measure the volume of a regular object. And this is something you've probably all done in math class. Essentially what you need to do is simply measure the length, width, and height and multiply these three together to find the volume. So we have a width or a length of 10 centimeters, a width of 8 centimeters, and a height of 9 centimeters. And using a calculator, or for some of you, maybe your head, you can come up with an answer of 720 cubic centimeters. Now measuring the volume of an irregular object is a little bit different, and we're going to use the water displacement method to do that. And we'll practice this a bunch in class. But essentially what you do is you measure the volume of liquid with the object inside of it, and from that you subtract the volume of the liquid alone to determine the difference, which is the volume of that object. So in this case we have about 265 milliliters of volume with the object inside. Without the object we have about 200. So the difference between those two is 65 milliliters, and that would be the volume of that irregularly shaped object. As I said, we're going to practice all of these techniques in class. This is just a brief introduction to measuring volume and the metric system in volume. Thanks for listening.